Okay, everybody, we are ready to go into our graphing calculator to do the actual pivoting of this initial tableau to get to our next and then final optimal solution. So as a reminder, I've got our ratios here reminding us what our pivot column, row, and element are. And then I've grabbed out my graphing calculator and I've input into matrix A. It's the easiest if you will use A because it's on the top. Do a 3x7 matrix and enter all of these elements in, and then you're ready to start pivoting. So the first thing we want to do is change this 5 into a 1, and then we will change the 3 and the negative 10 into zeros. So to change a 5 into a 1, we need to multiply by 1/5. The decimal version is easier to type in though, so I'm going to say 0.2 times row 2, and that will become our new row 2. Okay, then once that's a 1, we're going to multiply by -3 in order to get rid of that 3. So we're going to do -3 times row 2, add that to row 1 to make our new row 1. And then we'll multiply by +10 row 2, add that to row 3 in order to make our new row 3. Okay, so now I'm going to do a second quit to get myself back out here, and I had done some earlier stuff, clear that all out. Okay, so we're going to go second matrix, and this time we're doing math. We want to do first just a times row. We're multiplying by 0.2. We're doing that in matrix A, and we are doing this to change row 2. And then make sure again that you always store that second matrix A again. Okay, so I'm going to copy down my new row 2. I have 0.2, 1, 0.2, 0, 0.2, 0, and 1.6. Okay, now I'm going to go back, second matrix, math. This time we need to do a times row plus. We're multiplying by -3. Make sure you use the little negative, not the minus. It will yell at you for that. Do this to matrix A. And we are doing this to row 1. Ooh, sorry, I need to fix this. We're doing this to row 2 in order to change row 1. No, I'm good. So row 2, we're doing this to in order to change row 1. And store that back. Oops, so store back into matrix A again. Okay, so my new row 1 is 0.4, 0, 1.4, 1, -0.6, 0, and 5.2. Okay, one more. So second matrix, math again, times row plus again. This time we're multiplying by 10 in matrix A. We are doing this to row 2 in order to change row 3. Close it up, store, back into matrix A. Okay, so our new bottom row is -6, 0, -5, 0, 2, 1, and 16. Okay, so remember, in order to be optimal, all of your entries below that line and to the left have to be positive. So we're not all positive here. We've got 2 negatives still. So we know that we're not optimal. So we have to start this iteration process again. What is our pivot column? Well, that's going to be our most negative entry. That would be our -6. Then we need to look at our ratios in order to figure out our pivot row. So if we take this 5.2 divided by the 0.4 here, that actually gives us 13. And if we take 1.6 divided by 0.2, we get 8. So there is our smallest non-negative entry. Where those two meet is this 0.2, so this is our pivot element. So this was our pivot column and pivot row. Okay, so we're going to do this process again. First, we need to change that 0.2 into a 1. The opposite or the reciprocal of 0.2 is 5 because 0.2 is the same as 1/5. So the first thing we're going to do is take 5 times row 2, and that'll be our new row 2. Once that's a 1, we're going to change the 0.4. So how we're going to do that is we're going to do a negative 0.4 times row 2, add that to row 1, and that will make our new row 1. And then we have to do the opposite of the 6, or the negative 6, so we'll do a positive 6 R2 plus row 3 and make that our new row 3. So I've given my directions there, and now we're going to go ahead into our calculator and do it. So again, second matrix math, first do a times row. This time we're taking 5 in matrix A, and we are doing this to change row 2. Store back into matrix A. Okay, so I'm going to go again across, and I'm changing this middle row first. I get a 1, 5, 1, 0, 1, 0, 8. Okay, next, second matrix math, I need to do a times row plus this time. This time we're multiplying by negative 0.4 in matrix A, and we are doing this to row 2 in order to change row 1. Store back into matrix A. We get a 0, a negative 2, 1, 1, negative 1, 0, and 2. And one last time, which is not going to be surprising since I have already kind of pre-made our matrices for this. We need one more times row plus. This time we're multiplying by 6 in matrix A. We are doing this to row 2 in order to change row 3. Store back into matrix A. We get 0, 30, 1, 0, 8, 1, and 64. So what we can see here is this is optimal because there are no negatives. And where are there no negatives? There are no negatives over here. Okay, so how do we read the final answer for one of these? So to determine the optimal solution, it says the value of the variable heading each unit column is given by the entry lying in the column of constants in the row containing the 1. The variable headings of the columns not in unit form are assigned a value of 0. Okay, so that is kind of hard to understand maybe, but what this means is look at your unit columns. So your unit columns are the ones that have zeros and a leading 1. So in this case, I have 3 columns in what we would call unit form, where they have a 1 and everything else zeros. How we read this off is every time you see a 1, you want to follow that all the way over to the constant and it gets that value. So this x1 value is an 8. This y1 value is a 2. And this p value is a 64. And then what it says is that everything else is assigned a value of 0. Anything not in that unit column form. Oh, I'm sorry, I accidentally reversed these two. Please fix that. So the y1 was a 2, the y2 is a 0. Okay, so how do we read this off then? For the final solution, remember we were maximizing p. So this right here is the maximum value. The maximum value is 64 in this case. And if you go back, remember that the ordered triple, the 3 variables that we started with in our equations were x1, x2, and x3. So this is the point where it occurs, that it occurs at the point 8, 0, 0. We don't really need the y1 and y2s, those slack variables. That's what they end up being, but they don't really play into any final answer usually that you're going to give. They're important, but I think that as far as your Newton homework, Really what they ask you for is this. They will ask you, what is that maximum value? They may ask you what point it occurs at, and so you can also read off that ordered triple if you need to.